Is Mr. Lamb coming to you with another video tutorial for you. Today we're going to be looking at chemistry, particularly at metals, metalloids, and non-metals. Now, as we go over this today, I really want you to, the focus of this is going to be looking at the properties of metals, non-metals, and metalloids, and then also their position on the periodic table and how reading the periodic table you can tell certain properties about different things. So, getting started real briefly, this is in the chemistry section of your studies, and chemistry is just the study of matter and how matter changes. And then quick reminder on what is matter. In elementary school several years ago, you've probably heard the word matter several times by now, but matter is everything that's out there. It's basically the stuff, the material, whatever has mass and takes up space is matter. Now, matter can be very similar. Sometimes it's very difficult to tell what one thing is versus another. For example, with the two rings you see here, just by looking at them, it's not possible to tell, is this one real or is it fake? Is it a diamond or is it cubic zirconia? I mean, maybe some jewelers are out there that can do it by sight, but normally they've got to run certain tests. So, scientists, we look at stuff and we want to break it into nice groups. In order to put it into its group, sometimes we have to look at its smallest parts, which would be the atom. For middle school science purposes, really atoms are about as small as we go. We do look a little bit at their subatomic particles, like the number of protons, neutrons, and electrons. But looking at its atoms can tell us a lot about the properties of a substance. So, matter made of just one type of atom, is called an element. And each element does have a unique mass. That's one of its physical properties. And we've already discussed several elements, things like copper or chlorine, aluminum, neon, and you can see there are lots of different things. The periodic table of elements is that master list that contains all the different elements known to man. So, on that periodic table, we divide it into three groups, our metals, our metalloids, and our non-metals. You see, when chemistry's been around, scientists have been studying stuff for years, and we've known there's certain metals and non-metals, and there's certain things that have properties of both. But for a while, we didn't have a way to organize it. Before we created the periodic table, things were just kind of placed around. But it was not a really good way to organize the elements, and scientists like organization. We like being able to put things in their right spots. So, Dmitri Mendeleev, the father of the table, created something to help organize our list of elements. And he organized things in rows and in columns. And to give you an idea, the groups, the vertical columns were called families. And if you're in the same family, you have certain properties. And then he had horizontal rows. And if you're in the certain rows, you have the same property. If you're looking here on the PowerPoint, you can see how row 1 only has these two elements on there. That is hydrogen and helium. Both gases there at the top. But then you get down to row 2, and there's a few more. And there's reasons for these rows. They share properties. All right, so broken down, we can see that when the elements are arranged in order of mass, the periodic table forms. So we're basically organizing them by their mass, like I said. And please remember, each element does have an abbreviation. It's got its symbol. And he came up with this layout. Mendeleev came up with this layout basically in 1872, and he did create the three main categories at that point. And the three categories were the metals, the metalloids, and the non-metals. So let's look at where they actually fall on the periodic table. On the left side of the periodic table, you have the metals. Metals are typically classified by being very shiny, they're metallic, they're good conductors of heat and electricity. That's a big one. They are malleable and they are ductile. Remember, malleable is the ability to mold something into a shape. Ductile means you can basically draw it into a wire, draw it into thin strands. Things that fit this description would be copper, aluminum. Very common. Most of us can recognize a lot of metals. Nickel and gold. Everybody likes gold. But now some are going to be a little bit different. You notice everything you see right now is solid. There's going to be a couple, like mercury, where metal can also be a liquid at room temperature. So just in normal, regular old circumstances, mercury is a liquid. It's still shiny, still a good conductor, but now it's liquid, so it takes the shape of whatever container it's in. Silver's another good metal. It's pretty. People use it for lots of things. Now look at the periodic table. You can see it's basically the left side are the metals. And this does comprise the largest portion of the periodic table. We can see here, there's this diagonal line. And it's not really diagonal. We're going to see in a minute, it's really a stair step. And we're going to check this out. You can see the stair step I'm drawing in here. But we'll get to that more when we talk about the metalloids. But this big chunk, most of the periodic table, metals. Then we get to the metalloids. They're on what we call the zigzag line of the periodic table. This is the intersection where the metals and the non-metals meet. Most of them are shiny. They typically look very metallic, but they're only semi-conductive, meaning they only let some heat and electricity through. Because of that, a lot of these are used in things like semiconductors and are processors for our computers. They use them a lot because electricity, the electric signals will still go through, but it doesn't transfer as much heat. Therefore, you can keep the heat load down your computer. It doesn't overheat as much, and it's very helpful versus using old like copper conductors that were in some of the first chips. Now, often they will combine these metalloids with nonmetals to make things. If you look at the periodic table, they are kind of an odd section. Your periodic table and the ones that you have on your star charts will have a dark stair-step line off to this right-hand side. And that's the boundary. Those elements on that stair-step line, you can see those are where your metalloids are found. Things like we have boron up here, and we have silicon here, silicon chips. That's we were just talking about the semiconductors. So you can look at your periodic table and look at this a little bit more. But those are your metalloids. Form the boundary between the metals and the nonmetals, which leaves us with our last section, the nonmetals. This is the right side of your periodic table. These things, they're not shiny. A lot of the items over here are the gases. And then when we look, when we get a little bit more into your periodic table, we'll see things called noble gases in there as well. But these things are not conductive at all. Heat and electricity are not going through these things. They are not malleable. They are not ductile. These things are brittle. They will break or crumple. Now, obviously, if it's a gas or a liquid, it's not going to break or crumple. But things like our carbon. Carbon's very, very common. Your charcoal briquettes have a lot of carbon in there. These things, you're not going to shape and mold them. They're going to break apart. Your gases like neon and helium, they're going to have different properties from metals. These are, usually you can tell the metals and the non-metals apart very easily. It's when you're getting into the metalloids that sometimes it gets a little bit tricky. All right, so this section of the periodic table in green you can see are your nonmetals, all to the right-hand side. The only one that's special is your hydrogen over here on the right. Or I'm sorry, over here on the left. That hydrogen is connected with the helium, and that forms our first row. But these are going to be your nonmetals. For the most part, all your nonmetals are over here. Then you've got your stair step, which we just saw, were our metalloids, and then we have our metals on this section. All right, so that kind of concludes this brief overview of, let's see, no, we don't want to keep those. That concludes the overview on metals, nonmetals, and metalloids. We will get into testing these different things on a separate tutorial, but this kind of helps you see that based on where you're looking on your periodic table, you can tell different things. You'll be able to tell something, is it a metal, is it a non-metal? If it's a non-metal, is it non-conductive? You're going to know if you have an element that's on the left-hand side of your periodic table, those things are going to be good conductors of heat and electricity. If it's on the right-hand side of the periodic table, it's going to be a poor conductor of heat and electricity. So based on its placement, you can see a lot of stuff. And if you need help, watch this tutorial again, talk to your teachers, and we'll see you next time.